Okay, this is an application of the last theorem that we have done. The statement was every Bernoulli sequence of random variables obeys the central limit law. That theorem was also known as demoivre Laplace theorem, and this is an application of that theorem. Now consider 144 throws of an unbiased die and consider the event E 1 or 2 or 3 appears. So when you throw the die, this is the event, that is a number less than 4 appears. You know that there are 6 faces of the die, so any of 1 or 2 or 3 appears, then we define the event E. Now the problem is to find the probability of getting E at least 66 times out of 144 throws. And number 2, the probability that E lies between 72 and 78. That is, the number of times E will occur lies between 72 and 78. So this is the problem. Let us first define xn is equal to 1 or 0 according as the nth throw results in E or E complement. What is E complement? E complement is the appearance of 4, 5 and 6, either 4 or 5 or 6. Okay, we define xn. Clearly xn is a Bernoulli sequence of random variable with probability of success p is equal to half. Okay, this is very clear. This is very clear, no problem, because we have only two mutually exclusive events, either E or E complement. E is 1, 2 or 3, E complement is 4, 5 or 6. Okay. Now put xn is the partial sum xk, k goes from 1 to n as usual. Then Sn follows binomial n and probability half np, so that expectation Sn is np, n into p, and the variance Sn is n into p into q. So half into half is 1 by 4, so n 1 by 4n. So when number of throws n is 144, expectation Sn will be half into 144 is 72, and the variance of Sn will be 1 by 4 into n will be 36. So the last theorem which says that the last theorem, we apply the last theorem. So the probability, the question in the problem is, as out of 144 throws, E will appear at least 66 times. So E will appear 66 times means if E appears, then it is a success. You count the number of success. So S of 144, Sn, this is Sn, n is 144, is greater than or equal to 66, because we define xn is equal to 1 if E appears, 0 if E complement appears. So counting E means you sum it, the sum of x1 plus x2 up to xn. So 1 plus 1 will be there. So this number will be the number of E's in out of 144 throws, greater than or equal to 66. Okay. In order to apply the last theorem, this is Sn minus expectation Sn is 72. Square root of variance of Sn is square root of 36 is 6. So you apply here from here. So then this is Sn minus expectation Sn by root over variance of Sn. So here 66 minus 72 by 6. So this is equal to probability, this will remain greater than or equal to minus 6 by 6. But we know that this quantity, because of the last theorem, follows normal 0, 1. This is equal to, since it is follows normal 0, 1, minus 1 greater than or equal to a variable. This is a abuse of notation. This should be x, but we simply write like this. This integral minus 1 to infinity normal 0 1 means this is the probability here. You see, this is minus 1, and this is a random variable which follows normal 0 1 distribution. So probability of this variable greater than or equal to minus 1, meaning integral probability integral minus 1 to infinity normal 0 1. So we put like this. So this is equal to, simply you remember, normal probability curve, the whole curve is 1, so 1 minus 1 to infinity will come, minus 1 to infinity, then 1 minus 1 to infinity is same. You draw the normal probability curve. Here it is 0, here it is minus 1, here it is 1, then you do that. So this is from standard normal table. Minus 1 minus some probability will come. After that you subtract it, and this will come. So do not bother much about this. You can, if you are able to look at the standard normal table, you find out this and subtract that from 1, and you will get this. This solves 1. And now for the second problem, probability is 144 lying between 72 and 78. This is the same. So in the middle we have the normal 0 1 variable, because Sn minus expectation Sn by root over variance of Sn. Similarly, you subtract from here also, do the division. You subtract from here also, do the division. And this will be, after simplification, 0. This will be 1. So the integral will be from 0 to 1, normal 0 1 simply. So this is equal to half minus 1 to infinity normal 0 1. So this also you will find by opening the standard normal table and find the value of this. After that you will get this, no problem. So this we solve both 1 and 2. So this is another example. This is another example. You try this one. You work yourself in the same way as I did, and after that you also work this. Do not bother about much of the numerical values. That will be the answer. You simply work out the theory, how to reach at this, what are the questions asked, and how to solve this problem. Okay, so, and you show me in my personal WhatsApp. You show me in a blank sheet. You try to solve both these questions and you show me. Okay, up to this only. I will upload it and you try to understand. Have a good day.